I'm with EnOcean. We do energy harvesting wireless technologies. So we're the world leader in self-powered devices. We've got a patented technology that's mature. It's out in the industry. We've won all kinds of awards. We were founded by the Siemens company in 2001. We were spun off from them in about late 2001, and all of this technology was developed in Germany and is now supplied to quite a few different manufacturers around the world, about 200 different manufacturers developing about 800 different products using our technology. So, we've sort of become the standard for self-powered wireless in sustainable buildings in different countries around the world. One of the gentlemen here was talking about different things from France and Germany and different things. And Germany is just leading the world in energy efficiency. And one of their things is they couldn't put batteries in buildings because you have to pay for the recycling of a battery up front in Germany for 20 years of recycling, so it's cost prohibitive. And so anyway, so that's sort of where the history of the technology. Kevin was nice enough to send me some questions that we should kind of cover, and I'll try and get through these quick. So we do lighting and HVAC. We do pretty much anything that can be or should be turned off when you're not using it. That's what we can control. We can work with LEDs, fluorescents, incandescents, HIDs, high base, whatever. And we work to just turn the lights off when the space is vacant. I mean, it's occupancy-based technology in that particular realm. Those have been around for 30 years. Your energy savings are anywhere between 25 and 60%, depending on which agency you look at. It's proven, it works. I mean, our occupancy sensors are self-powered, so you just stick them to the ceiling. They run off the light in the space. So there's no batteries, there's no anything, just sticks on there and communicates wirelessly to the lighting in the space. You can also use this same device that's controlling the lighting to control the HVAC. So we can simply exchange the thermostat with one of the thermostats with our radio in it, and this same sensor that's doing the lighting can now do the HVAC. So we've sort of taken down that wall between the HVAC technician and the electrician and brought the two together so you don't have to have duplicate sensors doing the same thing or complicated interfaces to get the two to happen. So neither option, whatever you decide to do, requires a huge, complex building-wide system to achieve different energy savings and different things. We can do it right at the room level. I could do occupancy sensors in here and never leave this room, but still turn the lights off when nobody's in here, which is ultimately our goal. So we perform best in retrofit environments. So we work when we can come into a building and not tear up the walls or the ceilings or disrupt the tenants, that type of thing. That's sort of where we perform the best. That's where we find that our current market adoption is the best. And it's also, new construction is forecast next year to be down 3%, negative 3%. And so retrofits is going to continue to be one of the big demands for our products. We basically replace the wire and the associated labor and the disruption. So if we had to go from, say, that thermostat up to an occupancy sensor, I could do it in about 10 minutes. I wouldn't have to do anything but get a tall enough ladder to actually stick this to the ceiling. So there wouldn't be any ceiling tiles removed. I wouldn't have to cut the drywall. I wouldn't have to do anything that way. So pretty simple setup, very, very easy, and can also be scaled up to the next level. So we estimate the energy savings to be about 30%, but like I said, depending if you talk to the DOE or the EPA or whoever, occupancy-based systems are 30 to 60%. So there's a huge range. It depends on your building type and use. A couple of case studies. This is a current installation. This is the UC Santa Cruz Library, their science and engineering library. It reduced the entire building's energy consumption by 40%, not just the lighting circuitry, but they actually reduced completely by 40%. I believe this one had some funding from PG&E, and also their estimated annual energy savings are $48,000. So they estimate that this one will pay for itself in 2.65 years. So it's a great project, beautiful building, 2,200 light fixtures being controlled by occupancy sensors and relays. No upper level building management system. It's all done locally. and they, I believe, are currently in the process of taking that to a tritium Jace so that they can actually have visibility of it just for that next sort of step up. Huh? This one is actually very well documented. It won the California Higher Education Sustainability Conference Award. I believe it won the gold. And then we just gave it the Wireless Innovation Project for 2011 at Greenbuild. And so I have quite a lot of data on this one, so be happy to share it. You know, we're seeing this huge volume in retrofits in Europe. Our it's absolutely exploding. You know, we're trying hard to keep up with the growth, but it's what we see here coming in the next year or so. You know, the DOE estimates that 82% of commercial buildings in the U.S. lack any kind of automated controls at all. So if you can walk in with a 5 or 10 minute installation and walk out, you know, you'll have this very simple, non-elegant, quick solution that gets you in and out of the building and achieves your energy savings. And you know, some of the market barriers that we see are knowledge of the product availability, actual people knowing that this is out there, even though it's available in 3,500 distribution points across the country. We work with some of the larger corporations like Leviton and some of the different brands that are out there. They have 25,000 SKUs, and so you know, it sort of just gets lost in the mix. So I think as soon as we can start to really educate the market about the benefit of energy harvesting powered devices, we'll start to see this uptick in the market acceptance here in the U.S. And we count on the emerging technologies divisions of different utilities to help us with that. So we've seen some growth in certain areas where that's occurred. So installer education, we've done some of the Cal CTP programs. We work with the CLTC. We've worked with NECA and some of the others to kind of train some of these different people. I think we've now trained through Cal CTP. I want to say it's 150 trainers that are out there training electricians, so that's good. And then obviously the building owner capital expense is probably the same thing that we all face. So again, incentives and different things help with that. So current status, we are currently installed in a little over 200,000 buildings worldwide, so we have a pretty good footprint of different things. We have millions of units out there. So this is definitely a proven technology. It's been around for 10 years, and there's not a lot of new things that pop up here and there. So you know, we definitely have seen that. The non-energy benefits are going to be the same as anything else when you turn things off or set things back or whatever. You're going to have less maintenance on those because they run less. You're going to have you know, bulbs that last a little bit longer because they're not on all the time. So different things like that. So we've also found that it's been proven through the USGBC that efficient buildings end up with a higher valuation in rental income because your operating costs are lower. So that's been a driver as well. Demand response capabilities. I know that everybody is talking about DR all across the country and the world, and in Europe DR is a pretty regular thing. It's done fairly regularly in different countries, Germany in particular. And so we have several ways to do this. If you drop in one of our occupancy sensors and a receiver switch, you now have control of that space from a wireless signal. So you can easily drop in a TCP/IP gateway or a BACnet gateway or something else, and then we can take pretty much any DR signal that wants to come in, whether that comes in wirelessly or wired or via the internet or you know, text message or however those come in. Through the paging systems, I guess, is another one. We can take that and translate that into a pattern of things that can happen in that building. So you can say, okay, well, I want to set back all my dimming capabilities. I want to set back 20%, and you just make that happen. It's basically like setting up a scene, just like you have in this room here, where we have the two front and back rows of lights off. It's the same exact setup in our software. So when you do take it to that next higher level and you add that access point and the different things, the software is capable of handling that signal and processing it automatically when that comes in. That software is also included free of charge with the TCP/IP gateway. So gateway's, you know, X dollars, it's not very expensive, and the software is not then a $20,000 or $30,000 add-on on top of that. It's just included with the gateway, so that comes right with it, and that gives you control on your iPhone or your Android or whatever if you wanted, or an iPad or something if you really wanted to take it to that level. So we have gateways in, I would say, probably about 15 different protocols, from BACnet, Lawnmark, KNX. We can interface with Johnson Controls, the N2 and the Metasys systems, Tritium, Jace. We've got sort of, because we work with so many different products and so many different manufacturers, we've sort of had to bring them all together, and all of our profiles are published and available for people to just say, okay, so I want to listen to these 10 things, so I just need to know those 10 profiles and pull them right into an upper level system if they need to. So one of the other things that we like to point out is we can use existing fixtures and controls. So, you know, you can walk into a building and not have the capital expense of replacing every ballast or every fixture or every piece of hardware in that building. You can just simply turn off an old fixture. So I'm getting the stoplight, sorry. I must have missed the time warning, sorry. So I can keep running through here really quick. I'll just run through. So here's a couple of things. We did the Nestle Purina headquarters, 600 fixtures. The GlueMac Engineering was an Office of the Future project, which thank you to you guys for helping us with that. We really appreciate that. They beat Title 24 by 75% in that, and we mixed wireless and wired occupancy sensors, some from Leviton, some from Wattstopper. A couple different groups there helped us out with that one, so that's a good one. They're waiting for LEED Platinum. This brings you all the way up to that central control that I was talking about, and that's it. Sorry, was that a quick enough stop? So, questions?
Could you show the previous slide? Thank you.
So the question is, so your technology is basically the sensor, the thermostat, and the software that ties in with the existing energy management system or some other control system?
Yes and no. I mean, I kind of think of it as if we were a car company, we make the motor, and everybody else makes it into a car or a truck or something useful. So inside this, this is a daylight photo sensor here. If I can get it apart. We make the wireless communication and the energy management side of this device. So we manage the energy from the solar cells, and we capture that, and we collect it, and we make it usable, and then we make it communicate the data from the analog sensor that's in here. So we make this little part there, and somebody else makes it into a photo sensor.
Yeah, but you're not making the device that controls the lighting fixture or the HVAC system itself.
Correct. Somebody else does that, but we make those capable, and yeah, exactly.
You talked about, you alluded to battery level self-power. How do you manage power in the case of you're depending on ambient light to be your source of power and so forth? How do you manage the power that may once it's stored and perhaps you're for a period of time where you don't have any ambient light to feed you power? And is it just the sensor? Is this the occupancy control? Do you have any lighting? I mean, I'm asking several questions. Lighting, dimming controls, or any kind of daylighting harvesting?
Yeah, daylight harvesting, we use these photo sensors. So this is
okay, so you have photo sensor and occupancy controls.
And then occupancy control, and we also have some combined occupancy daylight harvesting sensors so that combine the two together and send two different signals.
So looking at this diagram, you have your control unit that's in the center of that spoken wheel thing. You have your fixtures, and then you have, what is that in the middle?
This is a gateway. So because we have so many different gateways to so many different protocols, we just showed a bare circuit board here. But that would take you to your next communication level. So if this building, for example, has a central system, we would need a gateway somewhere out in the hallway to communicate the sensor information from this room to that gateway to take you to that next level of architecture. So you would take that up to sort of that next piece. So you do need that gateway to capture those wireless signals and know what's going on, and also be able to send that signal out to turn the room on or off.
Okay. So you have your sensors, and then you also have to Randy's question earlier. I guess I didn't quite get it, but you have let's say in a dimming where you're daylight harvesting.
Right.
You would depend on obviously having dimmable ballast and dimmable systems, but you would also will depend on an existing dimmer
If you have one, you can work with it. Yes, we have the
if not,
abilities
you
to work.
also.
If not, we don't have any in-wall dimmers, but I have in-fixture dimmers that can go right in the fixture, and this is an LED dimmer that actually just won the best dimmer at the LED show in Las Vegas. But this one will be able to control a dimmer. We also have this same exact form factor that does a 0 to 10 volt output, so you can put that next to a dimmable ballast and do that. So yeah, so we sort of have those varying options. Yeah, so we can do with 800 different products. We can really do kinds of
So
lots
the
of
gateway
different
will
things.
give you the way to interface with an existing control system.
Yeah, so if you go up to that next level up, if you have a backnet system of some sort, say Delta Controls or something like that, or a Tritium Jace or whatever, you can actually use the gateway to get into that system.
Got it.
And so those gateways there's a whole bunch of those available. So I've got about 4 minutes left, I think.
Okay.
So what was your first question? I'm sorry.
I think it might have been about battery life.
Okay, so battery life is one that's really, it was actually about battery life, is more about what you do with the energy in the dark, right? So we do, we subscribe to California Title 24's manual on, auto off. So when you walk into the space, nothing happens unless you actually touch the switch. So you can obviously set these up for auto on if you want to. But if you have a situation where you have, a room like this that's got one door and window that's got curtains pulled across it, and this room's empty for 4, 5, 6 days, it might not auto on when you come in. So we work with the manual on, auto off system where you come in, turn the lights on, and then when you leave, 20 minutes, 30 minutes later, whatever, the lights go out, and we use that time that you're in there to charge this up just enough to turn off the lights. But this will store energy for 6 or 7 days in complete darkness, 100% darkness. And that time is sort of variable depending on a couple of factors, how bright it is and that type of stuff, and which product you're actually using, that type of thing. So, and battery life is a key one for emerging technologies too, because if you guys incent a battery-powered device and 3 years later those batteries start to die, you start to see all of your savings sort of fade off unless that building manager has taken the time to actually manage those batteries and replace those batteries. And the batteries then need to be replaced when they're still good. So you have to go through and have a schedule of replacing batteries. I mean, in the Hilton, New York, 2,500 rooms, they have 6 AA batteries in every single room, and they replace them every 18 months. So, there's this, and that's up to the building manager to actually go through and do that, and they have to replace those as they're still good, or else you get complaints.
Sort of a related question from a WebEx participant. How do you commission the individual sensors so that they are optimally, I guess, performing?
So there's multiple ways to commission. One of the ways, I can use this device here. We have a little red button on there. You push the learn button. This device, I don't have a screwdriver or anything, but you pop this little door off. There's a teach button. So you press the learn button here, you let it go, you press the teach button here, now they know each other. And this sends an occupancy sensor profile, so this one knows that it just received the signal from an occupancy sensor. So then there's different ways to configure that timeout with a couple of button presses here. We also have some PC software that can do that during commissioning. So.
So we have 1 minute, so in the interest of time, we'll take this as your last
Okay.
series of questions.
All right. Can you tell us what wireless protocol you use?
I'm sorry?
What wireless protocol you use between your occupancy sensor?
So EnOcean wireless is what we use. It's a protocol that was developed by the Siemens Corporation in 1999 for use in industrial applications, and it's a very fast, very low energy protocol that we have developed specifically for energy harvesting powered devices.
Which is then used to communicate to your gateway, which communicates via backnet IP.
Yeah, once you get to the gateway, you can communicate by whatever way you want. TCP IP, backnet IP, backnet MSTP. We even communicate using Zigbee, our competitive radio. So, there's a whole bunch of different ways that gateway and beyond is not our world. So we just go to the gateway and give them the hooks to change and get the data out to that different network. And we make those very, very simple for the different people so that they can just pull that data right out of the system without any hesitation at all.
And of the installations you have, do you have an estimate of what the capital cost of installation is per square feet?
Capital costs, it obviously varies, you know, if you're in an environment where you have union workers, non-union workers, conduit versus no conduit, that kind of stuff. You know, we've seen it anywhere from 50 cents a square foot to $2.75 a square foot. It really, I mean, you have huge variations. You know, do you want to do daylighting? Do you want to do occupancy? Do you want to do temperature control? You know, how do you want to kind of take that? What level do you want to take it to? And that determines what your square footage cost would be.
Okay, thank you.
Stop.
Thanks, Troy.